Okay.
So today our second and last class about statics. If in the previous time we working only with one body, today we are working with multiple bodies. As usual, question from the class. Nabil and Saif asked me to make a small workshop about home task simulation. Who made the simulation? How did you do it? So, how did you solve analytically? How did you solve? How did you simulate it?
Write equations for one of points, then derive others in simplify from the only parameter that then will be.
Did you receive the analytical solution fast, or how did you?
It is easy to derive. For example,
what solver did you use?
SymPy.
SymPy. I mean, what the method?
Just solve.
Solve, and it works.
Yes.
You say that it didn't work.
It works.
Yeah, because I tried to solve it. I actually asked him about it. I tried to solve it intersection of two circles for point C.
Yeah, me too.
And it's super complex.
Yeah.
And it takes a lot of time, right? But he solved it in a smarter way, like in a different way.
I had two substitutions in this solve. I replaced the coordinates of A points that were dependent from P. I replaced them with two other letters and then substituted them back. Because I waited for 10 seconds and thought it will not solve.
Yeah.
I use them on a file solver, it was okay.
So you solve it numerically. And how did you do it? I mean, so after this, what did you do? You received numbers.
I received numbers, so I used numerical differentiation to get the speeds.
Yes. And how did you put it in simulation?
Just by having the speed coordinates. I first, to form a vector, the first point is a point of, like if you want to find the speed for an A, the first point of vector will be the position of A, and the second point will be the speed in X and Y coordinates plus the position of a vector.
Okay, but I mean, did you make it in GeoGebra or using Matplotlib?
Python or Matplotlib.
Okay, so in this case, yes. What about others?
I used this.
What again?
This Py, I used this Py.
What is it?
Python library
For what?
for graphics card.
Okay, so I will show you how to do it in GeoGebra. Actually,
The Jabra died from important tables.
first of all, I like how Yaroslav mentioned the second home task. So he first tells can this shit even move? So after this he proved, I hope you also prove why it shouldn't move along all distance, because Grashov condition. I told you about this, so I hope you did it. If you already sent, or you will do it. Okay, so blah 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 blah. Actually, geometrical way, and after this ICV. Let's go to the GeoGebra. Actually, if you didn't know, you don't need to put analytical solution inside of it, because it can find intersection between two circles. So you put just one equation, second equation, and your solution point D will be intersection between 2 points. That's it. Even more, it can differentiate this point by himself. So they use IVC, because in this case you can just solve it graphically. Each time you can put, for instance, there intersections. So they find normal. When you need to find omega, they just took so they wrote there the normal perpendicular this one, so they find this normal vector, and so on. So you can do it fully geometrically there.
But it's unfair, like.
Why?
Because we need a table of values.
What do you need?
We need a table of values to create it before we simulate something.
No, you need to simulate. The task is to simulate. I didn't say that you need to have a table. We can open the task. There is no any words that I need to make a table or something like this.
Like in real life, how do you simulate?
I can take this and actually so in each point you have all answers.
But why can't we use solid coordinates, for example? Or can we? Like we thought we can't use solid because we need to calculate these values.
Again, he wrote equations. So for instance, this equation of the circle, the second equation of the circle, he wrote intersection between these two circles, and he finds this point.
Yes, GeoGebra finds this intersection, and then you can move point A and then see how this moves. But we can do the same thing with solid, but we told that we can't use solid because we need to find the positions.
So he finds position using he wrote equations in MATLAB. You're not writing, in Solid you're not writing equations itself.
Yeah, but you can say the angle, and then you will get positions, velocities, accelerations.
If you're doing it in fully parametric way, but you don't want to do it in fully parametric way, am I right? Yes, you can. If you make, you also can make in, for instance, in NX. I'm sure I know about it, or in Fusion, Solid probably. You can make a fully parametric stuff, but you're not writing equations. You're choosing circle, and after this you make constraints, and it finds your intersection. In this case, you find intersection using math. A bit another story. How did you find vector? Okay, how did you find vector when you move? If you make it in Solid and it will completely move, and you can receive the, let's say, I mean, equations. You will receive equations. Make it in Solid. I'd like to see it.
In GeoGebra, you don't receive equations.
Why?
Movement. You get a table of values. Like you can.
Actually, when he's solving numerically, he also have a table of values.
But he had it before the simulator. Like I also got a table before I simulated, and then put into this file and then simulate. Like here, he can first simulate, like construct these things with built-in primitives like circles, vectors, etc., and then get table of values. That's my point.
As we made it.
He even doesn't need to solve it in Python. Just puts point O1, O2, set circle O1A, O2B, then circle AB, and then GeoGebra will automatically find exact points.
But how can I do the movement in this case?
You start T, animation.
Because one of my points is t, and at least I have one equation which consists of phi with respect to t. Because c, for instance,
introduce value 5. Okay, I don't see how does he calculate velocities.
Velocities?
In Python or
so velocities a normal ort a01 minus 2 length of a01. So it's equation. It's not just something. Or actually they use IVC, instantaneous constant velocity position. They found this point in each time, and so.
Velocity and then found velocity.
So both of them did using IVC. So you can take derivatives, because it also can take derivatives inside of it. What else in 3D? As I mentioned, I said it's challenging, but you may see that it rotates and velocity is also changing. So you can do it in 3D. It's much more understandable what's going on there, rather than just plots. So you can do it in any Python, GeoGebra. I just showed it. Previous batch like GeoGebra a lot. They use Python and GeoGebra for some cases. So, for instance, next task will be provided. We will try to solve it at there using MATLAB. So calculation they are using SumPy. Okay. So I hope I helped you a bit.
Yes.
Okay. So now we're going to the quest. Bam. Don't forget to write fully. Research object, force analysis, and blah blah blah. Time to sleep.
Let's inverse. Has some surface. Go to this graph first. And we'll have so
You need to write force analysis.
what?
Force analysis.
So, what do you want me to?
Force analysis.
So, like,
Because you have, you need to draw and you need to choose coordinate system, and you need to show. So actually, where is MG?
what?
MG, the weight.
It's here.
Okay. Where is RA?
RA is what I assume like the pressure, and I'm
What's the definition of smooth surface?
smooth surface.
And-
It will be like from here, and but it will be the same thing, just different side from the other side. It will be exactly the same.
So I mean, what about the normal?
It must be tangential. I mean,
Perpendicular to the tangent.
yes.
So in this case, you have a circle. It's perpendicular to the tangent. That will be inside the end because of normal distribution. It will be just in the center. Of
Yeah,
it.
that's what I did.
Yes. But you didn't draw any RA.
This is I didn't write the name. This
Yes.
should be RA. This should be RB.
And want the direction.
But the direction will be different. Yes. So I can write it from here. I can write it from
Okay.
here. It will be the same thing. It's just different side. So we wrote like we have RB, RB. We can split it into its components. So on the x-axis we will have AX or RX. Was minus dx equals 0. So I will take my coordinates here. These are my 330, is it correct?
What other thing?
What is Py is this force. So I have my reference here, like my origin here, and this force. Okay. And we can substitute Py for n, like sine this angle, and we can just substitute n for the sine theta. And theta we can get it just normally because we know this length, and we know the r.
Mm-hmm.
And we'll get the theta, and theta will give us the n from the first equation, and n is the normal force.
Actually, do we need three equations there?
We don't need because the two forces are the same, and one of them will be redundant. We don't need.
You cannot say because that they are the same. It's your assumption, and in
Because
the end you will
no,
get
Is the load is
uniform distribution. Yes.
Yeah, and the distance is, because it's a circle, the distance is equal, so the force should be equal on both sides.
In spite of it, you can solve using two variables because you have two variables. You know the angle because you know that it should be tangent, and you know all length. You know that r, and let's say length. So you know this triangle fully. You know the sign. I mean.
This and this.
You know, yes, you all know all of this. So in this case, you can find angle.
Yeah.
Yes, in this case, you can solve a and b if you even don't know them, and they are different. Okay. Yes.
Just a different rule that RA and RB direct in the center.
That was my problem when I started solving, and it should be, because the definition of like the normal, like the surfaces, reaction force from the surface, is that you have, if you assume that this is a surface, then the force will be normal to that. And since this is a point, and from like kinematics, we can say that any curve, like, or any circle has like the tangent of it, the normal will be always going to the center of this curve, then we can prove that this like for the vector will be going to the center. Because this is a point, this point is tangent to the circle.
It was in the previous
Since
class.
it's tangent, then we can construct a plane tangent to this circle, and it will always point to the center.
Thanks, Safe. So, normal to the surface. Okay.
But if you calculate AB by Pythagorean theorem, it will be 1.4.
AB is given B.
Yeah, but if you
It's
calculate,
different from what you're saying, right? Like it's different from the actual
yeah,
solution.
here we have 1.6, but actually it has to be 1.4.
For the circle.
Why?
Hmm?
Why?
1 radius is 1. Yeah, 1 plus 1 square.
They want to say that it won't be in the center. They want to say.
I want to say that if we calculate AB, it has.
I got what it.
Okay. My mistake.
Okay.
Sorry.
Now we're going to move to this.
I really appreciate that he have yes, your comment.
Even if not
Blackish red.
Blackish red, yes.
blackish green.
Reddish green.
Blackish blue.
Okay. So again, we are starting from the search problem. We can understand that there are two bodies. One body and an four. One body BC and another body AC.
Sorry, because I always forget the dot that has like a hole in the middle. That means what?
This hole
Yes.
is joint.
Like
So
normal
can-
joint, like circular joint. Just joint. Okay.
Joint pin, I mean, rotational
Pin,
joint.
yeah, okay.
It's rotational
Mhm.
joint. Okay, we have two rigid bodies. It's BC, equating rotational joint. No, rotation motion. And AC, also rotation motion. Because it rotates and this rotates.
Bless you.
Okay, so now we are drawing the picture.
How is it fixed?
Actually, because we are in statics, it's fixed. But it rotates.
So AC is not like rigid.
AC is rigid.
It
is
cannot
not
change
straight.
his form.
No, it cannot change its form. Actually, you can think in terms of just take from A to C is the how to say.
Sorry.
Yes, the line.
Okay,
I also have trouble imagining this.
So we will study it when it's like static case, but it can move.
Yes,
Like
it
if
can
wants
move.
to
In our
move,
case,
if
it's
we push
it's-
it hard,
yes.
it will move.
Yeah.
So actually, if I want to rotate around this axis, we have this strange shape. But if this point also fixed, it will be just rotate like this. I mean, assume this guy, it's the shape is just let's say. Так, ты ничего не понял. Ты не понял, как это двигать дальше.
Вообще, как она может двигаться? Она же как бы статическая. Форма двигается, сохраняется.
Треугольник физически двигаться не может.
Он не будет двигаться, просто реакция.
That has a triangle cannot move by itself because it's not enough degrees of freedom.
То есть там два.
Yes, but actually, because this joint and this joint, it might rotate. So it fixed. We're in statics. It cannot move. But that about its rotational motion, because when we are talking about this, we are, how to say, we are isolated each body.
То есть вообще оно двигаться не должно.
Оно не двигается.
Ну,
Треугольник.
даже если мы не будем ставить статику, оно все равно не будет
Yes.
двигаться.
How can try to rotate anything from this?
Okay, it's more rotate, but why you have rotational motion?
Because we have joints. I told you we are talking about the latest one.
Joint.
Joint, rotational joint.
You can write joint to make it like less confusing. This. That's it.
Okay.
Okay, so
So, in this case, we can say that this guy is in support. So we do it like this. Because all are fixed, we are trying to solve a static problem. So support A bracket. This B also can support. And the last one, C, rotational ring. I hope you're understanding that C, say, I wrote it for one body, but we also need to do it for another body. Right, it should be also right. Android. Okay, now we are making force analysis. We know M is given. We know P1. We know who we make as concentrated force. Two because it's not two. No. Let's write O C. We know P2. And what kind of line? Rx A Ly A Rxb Lyb. Also Rxca equal to Rxcb So what I mean? So I'm telling that actually it's the same, but with different angle. I mean, direction. Is the reason why I call it just like this.
So since they are same, shouldn't it be 0?
They are not. When we talk about one body, you have external force. So what is okay? When, huh?
What is what you want to do?
Okay. When we're talking about forces, are we talking about external forces or internal forces or both of them?
We should be talking about external.
Yes. And when we're talking, so we have two bodies. How many equations do we need to write there?
For the two bodies. In
For
general,
each body we need to write 3.
yeah, so
So
in
we
general,
have 6
six,
equations.
but in our case, some equations might cancel out.
I mean, okay, 6 equations, actually more, because it's also one of the equations, it's constraints. Because when we talk about one body, we assuming that it's isolated from others. We don't know anything about this. Theoretic equation for this. After this, we know everything about this. And after this, we need to put extra equations which show that it's constrained. In our case, how can we show that they're connected to each other?
So, stroke policy.
Because yes,
What is constraint mean? What this line means?
this one.
Yes.
When we are looking from this body, we have to have external force, because what does mean force? It's interaction between two bodies. So this reaction, CA reaction, appears because of this guy, because we have touched it. When we call this reaction, RxCB, appears because of this, but they're the same. They're same magnitude, yes.
And RYCA equals RYCB.
Is the reason, yes, why they equal. Chandri.
Даже не знаю, как это сформулировано.
Let's solve the task, and probably you will get this one there when we solve it. From the equation.
Reaction of ring CA.
The third rule of Newton's rule.
Okay, I got that in the relation, but you wrote that reaction of CA at the x direction is equal to the reaction of CB at x direction, but at which point?
C.
Then it is probably not CA but C.
And the reason why I call it C. CA means that from this body, for this body. CB means for this body.
It was problematic. Just about this equation.
Okay. This now you understood. So in the end I called right curve C. And for the same for Y. So now we need to calculate how many variables do we not know. 1, 2, 3, 4, 5, 6. Okay. We don't know 6 variables, but we know that we can find 6 equations. Okay. We made first analysis, so we know how many unknowns, how many knowns, and so on. Now we are going to the solution.
So we just combine RxCA and RxCB just to like
Yes,
have at
because
the
it's
end
same.
six.
Actually, we can say that we have 8 variables.
But we can
We,
reduce.
we have 8 equations, yes.
But we can reduce 2 of them to.
We just, yes, we just.
Okay,
yes.
got it.
So now we are writing for the first body. So first body in our case is AC. It's first body. I chose point M because in this case we are reducing most of the reaction forces.
And if one possesses
Multiply on 3, it will be because we double the speed, it rotates clockwise, so bam, boom, 2, and because it was 4, actually I made a mistake, it should be not 3, but 4, only 4. So I found the type there. Point 8. Is the reason why I asked you to write like this, because in this case you can understand this point around point 8. In this case, 2, 7. Because again, plus Ly C A plus RxC on 3. Plus V1 sine alpha on 1.
What is R1 there?
What again?
R gamma. RX.
Okay, so again, it can be a bit trickier because you can forget about moments how to calculate them. We have this P1. On one case, in this, we rotate it like this, and our, let's say, the shortest distance between point M and this line will be 4. And when we put it like this, cosine alpha, we are moving in there. And in this case, boom. Probably not.
So it was given that point B1 is exactly on the same line with P2.
Again?
So point P1 where it touches like the
Yes.
yeah this point it is given that it is like on the same line with P2.
Yeah.
Yeah. Okay.
P2 was at the end. Yes.
Yeah, I changed, yes, remember? Yeah, I did it correctly. P1, sinus, rotated. So we consider this point, is like this, yes. Or we might take cosine and put it there. There are two possibilities, because we consider one before. you there, rotate, сюда, rotate, RX, rotate, and one, Так, еще раз, Андрей, вот
Consider P2 instead of P1 here.
no,
Which force is it?
this one,
Okay.
because we isolating this, we don't have this train. Again, it's a problem. When we are solving only considering one point and all external forces related to this. And the reason why I said that should be minus, because I made wrong concept. Bam. It is clockwise. So it's minus.
But
Where is X?
There. And Y there. So we wrote it one way. Let's see. We don't know this guy, what else? This guy, this guy. Yes.
okay. That's okay.
We don't know in this case. A, C, we don't know for variables.
And how should we find like distance to the P1 side of alpha?
In this case, again, put there shorter distance.
But what if it will be not from the end of the vector, in the beginning it will be 2.
Actually, we can
move it along the line.
Yes, we can move it there.
Yes.
Yes, we can.
So the shortest distance will be 2 if we move it.
As you may see that I have this plus this. Ты же можешь разбить силу на как-то на 3 силы, ну, по разным направлениям. А можешь, по-моему, так, и там... то есть это должно вот это найти. А это у нас получается что? Сюда переносим, вот так искать. Но это уже не очень удобно получается. Типа сил, как бы мы должны как y получить как усилие. Вот.
Мы просто разделили.
Да, мы просто разделили на так, да.
Ну тогда же
Нет, у меня у тебя вот это точка. У тебя вот эта точка. Ну, и поэтому одна пропорция. Кто запрещает силу высоты? Раз и два. Мы эту точку знаем, и вот. Я до этой точки искал так, а до второго.
если бы мы брали 2 здесь, то мы будем ставить.
Да.
Just one question. Why is the alpha 3/4 not 4/3? Which alpha are we getting? Like, can you
So
just...
we have
We need to find that.
this alpha.
But you...
So, sorry, tangent is
Yeah, but this will
3
not...
divided by 4.
But it will not be the same alpha for the vector P1, right?
Why?
Because the P1 is on an angle, and if we take like the parallel, alpha would be the angle like from the bottom, not the top.
This angle.
Yes, it will be like under the
So
line.
we find this angle.
No, it will be under the line.
So we found this alpha. What the?
Maybe I'm confused. Can I come 1 second? Because I can't explain it like in the air.
So according to the this,
So yes,
Yes,
the
it
under
is.
this will be alpha, yes.
so
But this, but we
We
need to
need-
find
we
the
need the
top.
other
It will
one.
be 4 over 3. Yes.
This one.
okay. Two mistakes in
Angles.
illustration.
Angles.
Okay. But the concepts are the same.
Yeah.
+1 to the current quiz.
No, can we make like previous quiz, not current quiz?
Okay.
This is a trick.
Okay, I'll give you for the previous one.
Thank you.
Okay, now we're going to the second one. Okay, X, RSB plus RSC minus D2.
What is X? RXB.
Well, it looks like an M, but
Looks
it's,
like M, not B.
but it's B. We understand now.
Where X
It's like B like
X,
RX.
and the X.
First one.
Yes.
Yeah,
X,
R.
B.
Yeah, it looks like M, not B.
Okay.
But it's okay. This is no the
The B, not the A.
the B is the
Ah,
problem.
okay.
Yes, but it's okay.
Okay.
Mhm.
So we have 6 equations and 6 again, only P2. Now, no P1, no anything, because we isolated. Actually, more dynamics works like this. For instance, Newton-Taylor method, which widely used in robotic simulators, you're considering, or you're trying to write full dynamics for each body, and after this, add constraints. It's complex. Lagrange working differently. I hope it's clear. Any questions? Okay, so try to solve on your essay.
Why science alpha? Like which alpha?
Solve
do
6
we-
what?
So it's not 6B.
Ah,
Do you really had ideal beams? Do you remember that it was one of possible, how to say?
yeah. So it's fixed to the wall and it doesn't bend, right?
Ideal beam, it's no, it's actually it's the same as it is. Yeah, spoiler. It's also ideal beam.
Ah, so okay.
You just need to solve the task from previous class using considering not as it's one body and it's just ideal beam join. You need to consider the second body and solve the task.
Какой альфа там выбрали, я так и не понял.
Игорь.
Олег,
Так,
что там
Олег.
альфа выбрали, я так и не понял.
Сереж, объясни. Да.
Какая альфа здесь? Вот это альфа, и вот это альфа.
Вот это альфа неверно, должен быть. Минус 90 минус альфа.
Ну, типа, если это альфа, то 90 минус альфа, это альфа, это 90 минус альфа,
Да.
можно было.
Да, это не нужно. Я ее играю. Да.
What's the purpose of different line thickness?
Игорь, иди домой. Представь, ешь на пальце. Игорь, иди домой. Игорь, иди домой. Ты что, не спал сегодня? Что ты все равно ты парень понимаешь, посмотришь видео. Иди домой спи. Я без шуток. Да, еще раз.
В чем причина, что разные волны? What's the purpose of different line thicknesses?
Okay, again, we have one of the, how to say, actually it's good practice to,
So it's not an accident? I thought it was just random.
no, I'd like to, Стоп, осталось 10 минут до конца пары?
Yes.
What?
All the time.
What happened? I didn't understood. Okay.
No, 20 minutes. 20 minutes until the end.
Okay. Phew. I will took it from this to the new one. Pump. So where it is, I remember. I saw it there. Read again.
What is the
So
name of
it's
the
not-
linear support?
Where the most of it's for black, for the don't have it
3D sliding.
No. So there is no.
Не слабо. У малолетного.
Okay, yes, more readable. Not the boy. So again, we have one of the possible, how to say, type of contact called ideal beam,
Okay, I will come.
and it's ideal beam. But actual ideal beam, we can also consider the second body. And now you need to try to solve it using consider the second body.
Wait.
Почему смотрели момент неправильно?
Потому что у тебя какое состояние будет?
Может, мы возьмем
Ты берешь по иксу и по y. Помнишь, мы здесь брали? У тебя эта сила равна нулю. Потому что мы ее сюда переносим, а мы
So
сюда
what would probably so this idea is that
You can just consider it
Потому
as
что
like
здесь тоже
last, so you can consider this as an ideal beam. It doesn't bend, it
у
doesn't
тебя вот
bend.
почти все.
So
И
just
по-быстрому.
two rotational pins.
there is no because it doesn't bond.
Because we have a reaction force always in the like the pin, so it will have a reaction force in the
Чтоб
pins.
Игорь проснулся, может доске?
Like exactly like how we did here. So pin support
One.
for us here we'll have rotational joint on point B and pin joint like
Yeah.
on the like I called it O, like the last point, the fixed point. And we just solved the statics. It's just namings.
Okay.
I remember we
Так. Окей.
So again, your case, you need to, let's say, add a new point, make a BC. No, not this.
А,
Yes.
окей. So, so IB is rigid.
AB is rigid.
And
BC
BC
is-
also. So, do we have any force? Okay, so we have gravitation force
No, you can omit it. Oh, okay, you can put it.
Huh?
Okay, gravitation force, yes.
Yes. Yes.
Put it in the center of the.
Okay. Just here. Okay. And
In this case for B2 will be C.
so it's yeah. Okay. So do we have any other forces?
No.
No. So okay.
But what about supports? You didn't write anything about reaction forces. You said that it's A, B, C rigid body, but it didn't give anything for us.
Okay. So looks like we have some reaction force, but it is not actually like in the air, so it's something like should be like that.
What are you doing? You can. Do you have reaction force according to x-axis?
No, because we don't have any force projecting to x.
Think there's a. Can you move in terms of x-axis freely? Yes, you can, because you have a slider.
Ah.
It's slider.
Yes. Okay.
So what do you have there?
So if we have in the reaction force, we have against y axis against base.
Okay, you have x or y. X, what else? Do you have moment there?
Huh?
Do you have a torque there? Reaction. I mean.
Yes, because we have several axes and they apply to different points on our body.
Because sliding cannot be bent. So again, probably some of you didn't get. We have slider. It can move in this direction. So we don't have reaction force on x-axis. Can we just easily go up? No. Can we rotate it? No. So in this case you have. Very soon I didn't get this picture. This is messy. So we have Ry and MA.
BC is not rigid.
We assume that it's rigid. It's not ideal right now.
It's like it cannot move, but it kind of can.
If you consider each body separately, then
We
you
say
can
that
analyze
actually
it.
we're just trying to solve the previous task using that. For instance, you don't know what is a green ideal beam. Now you're trying to solve the same task, but if you don't know that it's, you can assume that it's some kind of joint where you need to put just one, let's say.
Okay.
Yes. In this case, you need to try to solve it in, let's say, in classical way.
Okay. I see.
Okay. So
Okay, for this guy, so you need to write A, B, slider, R, Y, and A. What else? Which? What is it?
so this is the sixth.
I mean, actually, yes, we don't know. Support. Support point. So, support point C. What's it? Rotation. What does it mean by it?
Around
Why not?
Хорошо. Ну, понятно, почему. Единица только третья. Хорошо. This rotate. Okay. I understood. Sorry. Okay. So, in this case, we have on the phone.
No. You're talking about reaction forces. What the reaction force point C?
So it's in direction of.
So you should draw a bad picture. Is the reason why you cannot understand anything. Just draw it.
Now I hope to be better. Okay, so
With all this way.
so this moves, so this rotates, so the reaction force should be applied to the center, so something like that.
We can
Yeah,
choose.
you just hold.
So you can choose the direction of reaction force.
Yes, because actually in the end you will receive minus in this case you just need to change the direction. I rotate C and like C.
So,
Okay, this is point B. It's rotational drawing. It's support.
okay, so and also have
Moving body.
is
Point B it's connection between one body and another body. So it has four reaction forces. It depends on the body which
Yes,
is
okay.
about.
For example, we disregard this
In
part.
this case you can see
Look at AB.
AB.
It can move this way. Yes. So we have this BXX. Stop.
We just
And,
don't know, you know, because we can freely move like this. The reaction, like, reaction force should be more,
as
we can move freely X. So the direction that we move freely in doesn't have any reaction.
yes, according to the
reaction
machine
is the
Oh,
push
yes,
and
okay.
push.
Okay.
So we have
so
it only
for
in one.
B we
I
just,
see, okay.
So it would be
some
like
forces
because this
Mhm.
or
rotation limits you, like when you
Mhm.
try to bend up or bend down, it doesn't apply.
Okay,
we
so
have reaction force.
so having the two forces weight.
actually because of its ideal beam you don't have weights there.
Yeah.
Actually, I can.
Why? Correct. Okay.
And we have
so-
torque, since we have
Now
weight
this
that
case
tries to bend,
force analysis.
then there is a torque that is pulling the other way. So this only this is weight,
Yeah.
like in a distance.
Okay, so we
So
have
anything that we can multiply by
line.
distance, any force that we multiply by distance, there should be like a counteracting force.
Yeah.
Multiply by the distance that
force
pulls it
video.
up. So this is the torque. that we have.
Wait, this torque is around which? Around B?
No, it should be So because the weight is here, the force that is counteracting this should be around O1.
Okay.
You understand that?
So it will be almost like this.
Because A can be anywhere.
So I have my hands like this.
So we don't
So
have
there's
weight
a-
here.
I
Yeah,
want
yeah,
to-
yeah. It's like this.
Yes. So this is the weight,
Mhm.
and I want to push it up. So to be static in this direction, I have
And
to have like
Yeah.
push it, pulling. Like,
So there's a reaction force, right?
Yes, this is like not it shouldn't be reaction. Should be like because it's by the distance. It should be moment.
Yeah, moment.
Yeah.
Is it called reaction moment or something? But
Actually,
it exists?
Yeah, it exists. Like we have a moment for printing.
Okay, okay. I see.
And for B, we will have reaction for the four directions because it's a pinjoint, and we have like the analysis for the direction for in X and Y in relative to body AB and relative like alternative direction relative to body OB.
Mm-hmm.
So it will be something like this, like four direction.
Mm-hmm.
So when this, like ignoring this part,
Mhm.
we can see that when this pushes down,
Mm-hmm.
this pin joint tries to
Yeah.
push like in this direction, and we analyze it like
What is it?
it should be like we don't know actually like where it is. It could be like straight up, it could be straight to the side. We don't know, so we just like assume any direction, and we
Mhm.
just
Map. Yeah, project.
Yeah, we just project it and take the projection because it will give us like more
Mhm.
variables and like that will can help us solve.
Mhm.
We can do the same like hiding this body. We can do
Mhm.
the same for this.
Mhm.
And it will be always opposite to the other two directions. Why? Because this point is not moving.
Mm-hmm.
So the resultant forces on it should be equal.
Mm-hmm.
So this will equal this and this will equal this.
Mm-hmm.
It should.
Okay, okay.
Okay. So this point, since it's not moving, the reaction force from it to point O or C is exactly equal to the reaction forces from it to this body.
Mm-hmm.
So they should be equal, like when we analyze
Do
them.
we also need to compute the moment for this?
It should be because we have omega here, and this
Mhm.
should be like a torque on the other direction.
Yeah,
But I didn't get it.
I see.
Like I didn't calculate it yet.
I see.
So oh, and this also has two reactions. I forgot about this. Yeah, I was it. نسيت ان دي ليها two reactions بعدين فهمت ان انا بكتبهم هنا.
بس directions برضه زي
لا دي reaction
اه
كده
ماشي
reaction.
محتاجة بالك دي برضه
زي سي بالظبط. أنا حتى أقرأ بي إكس وأقرأ بي واي. هم دي.
Мы разобрали на игру здесь. Я думаю, мы пишем только для АБ сначала полностью. А, ну тогда мы должны разве формулировать? Сейчас назначим X,
We assume the direction of the reaction to be like some arbitrary direction here, because this length also affects this point. So it pushes, but it's like an angle. It doesn't push only from the side.
Mm-hmm.
It makes sense to think about it like pushing from the top, but
Mhm.
it has some angle. So
Yeah.
the direction should be like angle, and we just analyze it, like project it.
Mm-hmm.
Same here. And I'm not sure. We didn't get like a torque or a moment frequency. I'm not sure.
because it can
It's a pin joint effect. Can never mind. I forgot. So if you hide this body, yes, you can move.
Mm-hmm.
Yeah, because it's like a joint.
Yeah, okay.
Guys, pay attention. We consider the first body ideal beam. And when we're solving it, see Ry minus Ryb, equal to 0. X minus X, C and B equal to 0. And we have only one moment in curve. it's RYBC equal to BC equal to 0. It means that this equal to 0. We put it there, and again, so our Ry also equal to 0. Only Rx will be equal to something. Ideal beam, according to definition, have only x-axis. So actually we just prove it right now.
Ideal beam doesn't have an IC yet.
Yes. Is the reason we don't have y. Is the reason why our y direction will be equal to 0.
So when we assumed omega 2, which is like the weight
Yeah, I
of
dropped
this,
it because yes, ideal beam doesn't contain mass.
but yeah, if we assumed it,
In this case,
assume
it's not
then
ideal beam.
it will be like it will also result in
Yes, we
zero.
will have in this case, yes.
Okay, okay, got it.
Now we will consider A, B equations.
So time is up, yes, already. Unfortunately for you, because you have to learn this task at home, it would be. I'd like to aware you that you cannot consider that the tension from one and the second point are the same. They're different.
From what?
The tension
Forces, yes. You need to prove that they're same or not the same
On both sides of the rope, or you
On
mean
the both
around the
sides.
bullet?
on both sides. Try to solve by your hand because there is a solution on coding solution. But you have to do it. It's yes.
I don't understand this thing. What is the red block? Weights?
Wait, yes. So we try to balance this guy using 2 blocks and 2 tension. I mean, boom boom. Yes. This, I mean, it will be on exam. Also, you have. So let's watch this small video.
Yeah.
It's interesting.
Can we get this software?
I'd like to find this as well.
Yeah.
Again, why do we need statistical mechanics? It's Disney Research Center, and they.
Nice.
We discussed with Mo, so probably it can be a thesis for somebody.
Thesis?
Because it's about optimization. As you may see, they put how to say surface. So I'd like to have such.
So like
Yes, curve, and you need to how to say present the mechanism.
Not every curve can be presented like this.
no, they have to make it more complex, like more gears. They are putting like constraints on like 2 gears at once.
Well, imagine if you have really a lot of gears, all kinds of mechanisms. Any curve can be presented.
Yes.
Probably not, because you may see that we cannot achieve at this point.
No, but
If you make more, how to say yes,
yeah, more
more
complex.
gears.
He's asking like if we have everything,
Everything, yeah.
can we make like any type of curve? I guess yes. I'm not sure.
It's actually like, do you know that using only sine cosine rule? I mean sine. I forgot. You can draw a picture using on the sine and cosine equations.
Yeah, okay. Like, I see.
I tried to find this somewhere, but I failed.
This should be- Oh, so cool. Yeah.
It's your home task.
Wow.
and it moves really like real robot. I mean real object. Кротик, So for me it's interesting topic. If you want to work in Disney,
Oh, what is that gear? What the?
we will learn this kind of gears on next semester.
I know triangular and upload gears, but this one looks weird.
T-Rex.
He doesn't need this chair for work.
What is this?
In 3D. Scorpio.
Ah, Scorpion, okay. How, I didn't read the name. Oh, and you can do all of this with one motor, nice.
Yes, again, as I told you that.
I mean, like,
Is
you
why I
can
told
make-
it, because in theoretical mechanics course mainly we are working with one home task.
No, we didn't see any